On behalf of RBCS, RBCS New Zealand, RBCS Australia, and Software TestWorks, we welcome everyone today to this webinar on 6 lessons in software quality. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. We have offices in the United States, New Zealand, Australia, and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with a measurable return on investment. RBCS has a team of consultants internationally who deliver customized training, consulting, and outsourcing services for companies that are looking to improve their testing quality assurance practices. RBCS has helped hundreds of companies to reduce development and support costs while assuring the best quality products are delivered to customers. I am the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1 and 2, and very soon 3, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA, and I am also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. Before we start this presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them throughout the presentation via your webinar interface. There's no need to ask for presentation copies, as the presentation is posted on the web on our website at www.rbcs-us.com. There's also no need to ask about how to register for the free e-learning. Just by attending this webinar, you are automatically registered. Check your email over the next couple days and watch the spam filter to make sure the notification doesn't get lost there. You have a limited time to respond if you are the winner. If you are having problems with either the audio or visual components of this webinar, please contact GoToWebinar support. For whatever reason you cannot get to the webinar online, or if you're dealing with an unreliable connection, please download the slides from the basic library, which is on the resources page at www.rbcs-us.com, and be sure to use the telephone to connect rather than voice over IP. Most people don't have any trouble. We've had very few reports of people having to do that. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS, we're a not just for profit company. Okay, well, today's presentation is on 6 lessons in software quality. Do we know a lot about how to build quality software? Yes. Do we always do it? No. Can you build software quality? Yes, you can. But the missing piece is discipline. Well, let's look at some of these areas where we need more discipline to deliver a quality product. First, a little motivational background. Why should we care about this stuff? Well, brand image, company loyalty. Toyota, example of a company that's recently taken a hit because they did not preserve the brand image for quality that they had carefully cultivated over the years. There can be significant damage to market share. Those of you who are old enough might remember that the iPhone and iPad are basically Apple's second foray into the handheld device market, what used to be called PDAs, or personal digital assistants. The first foray was the Newton, and the Newton suffered from such horrible quality with respect to handwriting recognition, which was one of its key features, at least as it was promoted, that it was basically abandoned, and the product line ultimately canceled. And you think about how much money was made in the PDA market by companies other than Apple before Apple came out with the iPhone. You can imagine how much money was lost by Apple due to the very poor quality of the Newton. So there's real financial consequences to this. I'm sorry, I seem to be having an audio glitch. I don't see myself as being heard here. If you are hearing me, I'm going to, okay. I apologize. We apparently had an audio glitch, and my audio dropped out for a moment. So it seemed to be back on and working normally. Apologies for any inconveniences. So bugs, when they do occur, and maybe don't have the terrible results of brand loyalty issues and other loss of market share issues and those sort of things, you can still be fairly significant in terms of the cost to repair. And we see with a lot of our clients the problems of cost of failure that it's very often as much as 10 times the cost of fixing a bug in testing. So this can be, it's a serious problem when it occurs, and when this kind of loss of money on production failures, and certainly something that we should be concerned about. Apologies for the audio glitches here. I'm noticing that there might still be some going on. If you are having problems with the audio, then I do apologize for that. So time waste. This is another thing that you need to keep in mind about software quality problems, is that time spent fixing bugs is time not spent building new features. And so even if the company is not looking at the cost of failures in production as a problem, maybe they just say, well, it's the cost of doing business. Well, there are opportunity costs which are very difficult to measure, of how much money you would otherwise have had if you'd been creating features rather than fixing bugs. So that's as I said, it's difficult to measure, but it's definitely a possibility, and actually I think a certainty for most organizations, that time spent fixing bugs means a lesser delivery of features, which is basically reducing the profitability of the company. The bugs, quality problems, when they surface prior to release, of course, can cause delays in the release of software, which also lowers profit and market share. And if we're talking about safety critical systems, then there are safety issues that could potentially arise from quality problems. So this stuff is really serious, and there's no organization that's immune to these considerations of software quality. And pardon me. The good news is that we do know how to do this. We know a lot about how to build and deliver quality software, but it's not always done. So I've picked out 6 things that I think are worth focusing on with respect to that. And I'm going to go through those here over the next 45 minutes or so, and try to illustrate case studies of how how these six lessons in software quality showed up either as success when they were applied, or failure when they were not. And I'll give you some tips and some warnings as well as we go along. So here are the 6 lessons. Requirements. Have good requirements. Have testable requirements. Make sure that you think about quality risk throughout the life cycle and manage quality risk. Don't wait till the end. This throwing stuff over the end and assuming that you're going to test quality in is not a mistake we don't want to make. Integration and integration testing are the red-headed stepchildren of the software engineering life cycle, but that's unfortunate. They're quite valuable. Teamwork is essential to quality, competence is essential to quality, and change must be managed so that it does not negatively affect quality. So let's take a look. Start with the first one. So you have to know what you want to build in order to build it. So that means having requirements. Now, I want to point out that there's a lot of people talking about Agile lately, and some of our clients are using it. Some of them are being quite successful with it. In fact, I blog post about that recently, and it's it's good when it works. But I'll tell you, you need to keep in mind that if you go out on the internet, take a look at the Agile Manifesto, does not say no specified requirements. It doesn't say don't write anything down. Unfortunately, sometimes that's an interpretation that's put on it. But what it does say is that what running software is more valuable than complete extensive documentation. Okay, I certainly can't argue with that. But at the same time, our clients that are having success with Agile are putting sufficient detail into their user stories, as they call requirements, and they're checking to make sure that those are testable. So, whether we're talking about an IEEE style template that you're using to write detailed specifications, because that's the process you follow, or whether we're talking about user stories, the stuff needs to be documented somewhere, and it has to be understood. Because failing that, then you will have a very difficult time achieving quality. It's the equivalent of falling into a pile of money. It could happen, but it's not very likely. So very good things can happen when you do this, and problems with requirements can certainly be a source of a festering source of continued problems. So case study of problems, long-term costs associated with having bad requirements. We have a client that creates medical software, and it ended up, it had some serious requirements problems. They were vague, they were gappy, they were untestable, they weren't very well managed, they were floating around disparate and non-version controlled Word documents without even change management necessarily, the change tracking turned on. Well, it came to light at one point that dozens of these systems had some very serious data integrity issues, and these created safety risks. Now, fortunately, those were risks, and they didn't end up becoming outcomes. We were able to resolve the problem. It would have cost them hundreds of thousands of dollars to do it. Now, that served as a lesson, and they're now getting better requirements. They're using our Requirements Engineering Foundation course to train all of their staff in how to write good requirements, and that's good, and that's helping them. But that money is lost, and the risk that was run was unnecessary. So it's a near miss in some ways, but it's not a miss in terms of the cost that they ended up paying. Now, another client in the medical systems business, they created a template that they use, and it's machine readable. By that I mean it can be pulled out into XML format and processed because of the standardization of the template and the data put into it. So this it served them very well in terms of making sure that everything's complete and testable. And the reason they made it machine readable initially was to automate traceability, because they're subject to FDA audits, and the FDA wants traceability of requirements through to code and design and tests and test results and so forth. And so they had to standardize in order to make that work. Now, what happened was they found that not only was traceability enabled by that, but they were actually in a position to use it for testing. And so I worked with them to design a test tool, which they then implemented, that used the requirements, and it was what's sometimes called a dumb monkey type of test tool. If you're curious about how this works, you can see the articles page there on rbcs-us.com. The article's called Quality Goes Bananas, which is a reference to the monkey aspect of it. And that just is a tremendously useful test tool for them that they've gotten. They got basically for free out of parts pulled down, freeware and open source software pulled down off the internet, and threw together in the space of a few weeks. So, this is It's not something that they thought they were going to get, but they did get it. And you can, by reading that article, see if you can take advantage of something similar. Okay, now, risks. There are risks to system quality, right? By quality risk, if anyone's mystified by this, you haven't heard me use this term and explain what it means before. Basically, a quality risk is a bad thing that could happen that would affect the quality of the software as delivered to the customers. So, it can be things like system responds too slowly to user input, system calculates an incorrect total on a report, users find the opening screens too difficult to navigate and end up in the wrong places in the application. Those are all quality risks. And these things are visible in the design of the system and even in the requirements of the system. And they can be removed then, but sometimes they're not. So as a result of that, you can get a situation where there's a mistake in the design or the requirements, and so a component is wrong, and that component being central to the system, has a systematic effect on causing the system to experience a lot of problems, either in testing subsequently or worse yet, production. You can have interface issues that arise. The components are correct by themselves, but their interfaces weren't properly designed, and so as a result, boom, we get, again, systematic problems. And architectures and designs that are bad, it's very difficult to patch those problems out. What we found is cases, especially with things like performance and reliability, that those are often design-related problems, and when they occur in testing and they're serious, it's very, very difficult for those problems to be resolved in a way that's not really dangerous to the success of the project because of the impact. You start redesigning things that are central to the design of the system during late testing, and you're taking a big risk there, a big project risk of delay, and along with introducing additional quality risks, especially just in terms of regression. So use models. Models can be good to identify and remove quality risks during design. These can be static models like spreadsheets that try to predict the amount of resource utilization that's going to occur based on a certain level of load, or they can be dynamic models using things like performance modeling tools, of which there are quite a few available these days. If there are significant quality risks, test them early. Look for component integration and system test opportunities to attack things like performance problems, reliability problems, usability problems, as well as the functional problems. A lot of times people say, oh, well, you can't really test performance until system test. That is just completely wrong. That is not true. It's that people who wait to address reliability and performance risks until the system is fully functional are really playing Russian roulette on this. And I believe I've done a webinar on this previously, and if not, I'll do one subsequently. But this presentation that I've given, and as I said, I think I've done it as a webinar, that addresses this, how to deal with performance risks, performance load and reliability risks early on. So do try to deal with those early. We've seen situations, and I'll illustrate in a minute, where being surprised, unpleasantly surprised by problems in that regard is not something that can be solved by just throwing hardware at it. So here is that example. We had a project where there was a very senior technical guy created one of the spreadsheet models that I talked about, which, good thing to do. And it predicted a lot of the performance problems that later came up in testing. Problem was that people didn't follow up during design or any of the earlier testing that was done prior to the software being handed over to us for system testing. And we started system testing, and we found a ton of performance problems, like to the extent that the system basically was incapable of handling even about half of the load that it was supposed to handle initially. And so here's what happened, as you see on this screen. Our first test, you see that first line there on the leftish side of the graph. You see what's happening is that the response time is degrading rather dramatically. Let me try to use a highlighter on this to help illustrate this. Response time is degrading rather dramatically, and it's obviously, even in terms of linear degradation, not anywhere on track to be within the required response time, which is what's indicated by this hash mark over here, at the required level of maximum load, which is indicated by this hash mark over on the load axis. And then what happens here, the blue circle, is this indicates a point where you've got what's called a knee in the performance curve, and that's generally going to happen when some sort of resource saturates. It's about an 80% or above resource utilization. And then you see the response time really degrade, and basically we get to the point where it would crash. It was a Unix system, so it'd run out of virtual memory and panic. And okay, so throw more hardware at it. So they did. They threw more hardware at it, and that helped. As you can see, it's better. But again, too soon, we get to a knee in the curve, and then bang, and then it goes up and saturates and crashes again. So throw more hardware at it, and still not quite there, and still crashing below the required maximum load. So this is a peeling the onion kind of exercise, where instead of cutting through the onion, you're taking it off layer by layer. And of course, there's a lot of crying going on while the onion's being peeled. And this was a sufficiently serious outcome for them that actually led to the failure of the project, at least the project as initially conceived. They were able to scrape some value out of the ashes that remained, as it were, but definitely it was not anything anyone would have envisioned as a successful outcome because of this. And this is all avoidable because the model, as I said previously, had indicated pretty much exactly what was going to happen. Now, let's contrast this with success. So another project, we had a spreadsheet that was the type I just described, where you've got resource utilization predicted based on certain levels of load. And that was used to do an initial design for the servers that were going to be used to support this system. It's a distributed system of internet appliances. And then that was input into a simulation tool, a tool that now happens to be called High Performance. As I said, there are others out there as well. And simulations were run to look at response time, simulated response time based on, again, certain levels of load. That was further fine-tuned, so the design was changed. Different systems were selected. Now notice that at this point, nothing exists. There has not been a dime spent on hardware. It's all just being modeled at this point. It was only once they got to the point where they were confident that they had selected the right set of hardware, and simulation was telling them, yes, this will work, that they started to buy the hardware. And at that point, they're now coding, and they're doing performance testing, using things like profiling and so forth of the units and the subsystems, and comparing the results of those performance tests against the simulation results. So by the time we got to system tests, it was pretty good. The performance was pretty good. It was pretty solid. I mean, it wasn't perfect. We found bugs, but not bugs that indicated design problems that were insurmountable. So what's the lesson to be learned here, right? Iterative improvement of the models. Develop a model, check out the model. Okay, well, let's tweak this, let's tune that. Improve the tests. Look for discrepancies between what the models are saying and what the tests are telling you, and use that to improve as well. So, use what you learn from your modeling and your testing to course correct. Is an example of what I'm talking about of checking your models against your test results. So this is from our performance results presentation that we gave after the first cycle of performance testing. Now, this is a set of servers that provide service for internet appliances, and one of those services is email via an IMAP server. And what we've got is simulation data here. See, it says 45% server utilization at 25,000 users and 75% server utilization saturation at 40,000. Okay, so that's what it's predicting. All right. Now, draw your attention here. Again, get the Mr. Happy highlighter up here. There. That's one of the servers. This is another. You got load balancing across the two of them. Notice that the prediction is almost perfect. See that? 45% utilization. So what it was in terms of CPU is 41% utilization and 45% utilization. If you're curious about how this all worked, then as you can see here, there's on the basic library page, there's an article called The Right Stuff that describes exactly how we did this. Okay, integration and integration testing. Now, you know, this is the, as I said, the redheaded stepchild of the software life cycle, and that's too bad because it's very, very helpful when done properly. Now, people sometimes think, I mean, I guess this is the reasoning, I've heard this said out loud occasionally by programmers, is, well, you know, my unit's working. I've tested it, I've done unit testing, and it's working, and you know, if this other unit is having problems with it, then that's because it's not using it right. Well, that's one way of looking at it, but ultimately what we're talking about is an interface problem. You know, it's not like if you have a jar that's one size and a lid that is the other size, and obviously they're not going to screw together. It's not that the jar is wrong or the lid is wrong. It's that they're not designed to operate with each other. The lid is not designed to close the jar. So, you know, that's what we get into. We get into situations like this that it, you know, could be discovered in integration testing, but they aren't always. And you have situations where people are reusing units, and that's great, except that they don't necessarily do adequate regression testing, integration regression testing, and so you get risks. You get risks in this area. Now, one of the great things, of course, about agile life cycles is that they have led to a real resurgence in the interest of continuous integration, which is actually a really old idea. I mean, I remember doing work on producing a continuous integration system with built-in automated testing back in the early 90s, well before anybody had ever applied the word agile to software development. And we were doing 1-month iterations and the whole works. So these ideas have been around a long time. Continuous integration, very helpful to sniff out broken builds and interface problems of various kinds. And if you hook in a unit testing framework, you can build integration tests in that as well. And that will allow you to force these problems into the open. Now, this can be done in an Agile project. And, you know, in Agile, there's going to be sort of more methodological support for it, I guess you could say, or philosophical support, really. It's sort of expected in that situation. But this can also be done in a waterfall, too. And so, you know, whatever life cycle you're following, don't look at that and say, oh, well, you know, we can't do continuous integration because we're not doing Agile. No, you can do it. You know, it's certainly it's an approach, it's a technique, and it is life cycle independent. Classic example integration mistake is the the Ariane 5 rocket. So You had software incompatibility between one piece of software and another in terms of the type of information being passed, and that resulted in a navigational problem during the launch, and the rocket tipped over and basically had to be blown up because it was not going up, it was going sideways, and it was going to collide with something. So they ended up making it collide with itself, essentially, blew it into bits. The problem there was that they were reusing a piece of software that was incompatible interface-wise with a new piece of software. And that mistake, that one defect, cost $500 million US. So, this is, you talk about, high cost of failure. I mean, one bug that costs $500 million, that's a problem. Sorry, I'm having a little difficulty getting this to advance now. Went too far, and now it doesn't want to go there. There it is. Okay, so we implemented a system for a client that to help deal with this continuous integration system. It's unit component integration testing built into it. So the unit tests were testing the public and private interfaces in the units through various kinds of mock objects. The component tests looked at services and behaviors in the components, which were groups of units that did distinct things at various layers of the system architecture. And then we had integration testing, actual interface-focused integration testing happening between the different components. And there's continuous integration going on. And every 4 hours, the continuous integration tool and system would check to see if new software had been checked in, and if so, it would rerun all of these tests. So the very thing that created additional risk from an integration point of view, checking in a new module, would trigger the action that would push that risk back down, which is the running of this test. Article called Mission Made Possible on the basic library page. Again, on the resources page, we'll describe to you how this works. This diagram shows roughly what's going on. Is that the developers are doing development and running JUnit tests, and they're doing kind of test-driven development, though not really test-driven-ish development. But they did have a rule that they had to create a complete set of unit tests, and as well as component integration tests as they were building their stuff, and that would be subject to review. When they had their code review, they wanted to check in the code as final into the Perforce, which was their build server. And then every 4 hours, as I said, you'd have this cruise control application that would check out, will basically ask Perforce, you got any new code? And if Perforce said, yep, I got new code, it's ready for testing, then it gets pulled out. The J-test, Parasoft's J-test tool was used to do static analysis, looking for coding standard violations. And that information results are captured, and then you would do a build, and then that software would get deployed into a testing environment, and all of the JUnit unit component integration tests would be run, and all that output redirected into a status report, which was then emailed off to the respective parties involved. So, it's very, very nice closed loop system there, and something we highly recommend. Now, there's a lot of stuff out there to support this now, and lots of freeware that'll do static analysis for you now, as well as commercial tools. Of course, there's a lot of freeware to support unit testing, and you've got tools like Fitness. One of our clients that we're working with in December has this really nice implemented system where they have they got the end unit tests that they're creating, and then these fitness tests that they're creating, and it's all tied together into their continuous integration system, and it's really nice stuff. Now, again, these are ideas that are all strongly associated with Agile, but if you're not using Agile, don't say, oh, I can't do that because we're not Agile. No, that's not. These are just techniques, and these are applicable and have been applied in non-agile situations. As I said, they've been applied people, including me, before there even was anything that was actually called agile. So use them. They're great ideas. Okay, teamwork. We have people. Software is built by people, right? It's one of the most, if not the most, people-intensive engineering professions. You know, certainly if you look at other kinds of engineering, mechanical engineering and civil engineering and aeronautical engineering and so forth, that's more and more and more automated. So, you know, through software basically. So it's kind of funny that the software engineering is creating situations that make things much less, but it used to be very much brain intensive and people intensive much less so. Software itself remains, I wouldn't say immune to automation, but it's you know, less affected by it than you might think. Certainly we're not seeing situations where software is being automatically generated, and it's not on the radar screen for doing that. So I'm sorry, just excuse me for just a moment. I apologize for that. I was just interrupted. I'll be back on the call now. So everybody involved in building software has a role to play in building software and building quality in that software. The people, the requirements engineers, the business analysts, developers, testers, users, marketing people, sales, technical support, everybody has to work together to deliver a quality result. So this needs to be seen, quality needs to be seen as an objective for everybody. And one of the things that we've seen with clients is it's really important that people work together proactively and have good relationships. And I'm not talking about this from a like, oh, we all have to get along, you know, this is sitting out by the campfire strumming a guitar and playing, you know, singing Kumbaya or anything like that. What I'm talking about here is, you know, relationships that are positive, where people are happy to work together, are ones that can have successful results. So when people are angry at each other and there's a lot of dissension and so forth, that's going to slow you down. The energy gets redirected towards this negative situations and not towards creating a quality product. And once that breaks out, what we've seen is that that's a real death spiral for organizations in the sense of the relationships get worse and worse and worse, and it becomes very difficult to repair them. So let me give you an example of that. We have one client that had really serious antagonisms between various people's various teams. So we're doing a quality process assessment, and what we found very quickly on was that the non-test folks just said, hey, you know, testing has no value. And then the test folks said, well, the business analysts and the programmers are lazy and they take shortcuts, and, you know, basically it's the other guy's fault. Now the thing was that it wasn't really that bad. I mean, they have problems, but they weren't horrible. But you know, there were problems, and there were problems that they needed to make go away. So I got on the phone with the executives who commissioned a report, and I said, well, you know, I hate to speak in cliches, but you've got a classic good news, bad news situation here. The good news is you're about 18 to 24 months away from having real world-class quality. The bad news is that you can't get there with the current team because they will not work together, and the problems that you have are problems that exist because of teamwork issues. So this was a frustrating outcome. Having invested the money in having the assessment done, they now find out that the result is, you know, you're right there, but but your people are in the way. So this resulted in a decision ultimately to outsource all of the all of the IT work, which, so basically it's these guys were willing to fight rather than succeed together, and then it ended up being a situation where they were effectively signing each other's termination notices by not getting along. They forced a situation where they were basically redundant. The alternative example was another client that we worked with. We were doing a project. We were creating a leading-edge computer system, and we had requirements and design work going on in San Jose. We had a vendor in Taiwan building a part of the system. We had a component being built in Salt Lake City. We had testing going on in Taiwan. We had testing going on in Los Angeles. And we coordinated the activities across all these different groups. And they worked together as teams, even despite the fact they were from different companies. And everyone was happy. Everybody was excited about the project and being associated with it, and happy to work with each other. And so we ended up having on time, within budget, high quality system, a successful project. And dissension between any of those groups would have made that impossible. Okay, now good attitude is important, and also competence is important. People have to work well together, and they have to work well individually. When you have people that have skills problems, gaps in their skills, then they won't be able to create quality products because they don't know how, or they just don't have sufficient skills. They might know roughly how, but they don't have the skills to do it. They can't apply what they might understand. So a big part of managing software quality is managing the skills of the people involved in building that. Now, in terms of how to do this, how to manage skills, in my book, Managing the Testing Process, 3rd edition, there is an approach described, which is called the skills inventory. And the basic idea is you're going to do a task analysis, which is a fancy way of saying is you're going to look at kinds of work that actually is done by your team, or maybe that should be done by your team. Maybe it's not being done currently because you don't have anybody who can do it, but that it would be included in your task analysis. And then based on the tasks that you identify as being within your team's purview, you then identify the critical skills that are necessary to be able to carry out those tasks competently. And then based on that, you can measure the skills of your team against that set of critical skills, identify gaps, and start working to fill those gaps. Now, one thing to keep in mind is that stuff is hard. So there's, the software engineering is hard. It's as Fred Brooks put it, it's essentially complex task. And so it's not like you're going to go, oh, I have a skills gap, and so I'm going to be able to wave a magic wand and fix that immediately. You might have to reach out to people outside of your current team and pull in some consultants, pull in some contractors, hire some more senior type people to serve as mentors. And there's some work that was done, and it's in a book called Outliers. It's a discussion of this. It wasn't original to Outliers. Outliers was discussing this work that somebody else had done, and it cites this figure that it takes about 10,000 hours to master an intellectually complex task. One of the examples they use is Bill Gates. And they're like, why is Bill Gates such a success? Well, he's a huge success in part because before he even got to college, he already had 10,000 hours of programming experience. So he had this enormous head start, right? He was already an expert in programming. And that was the argument of the book, was this is why people who are really successful end up being really successful, because at a young age they master something. Now, that you might say, well, what good does that do me? I mean, if you're no longer at a young age, well, then, I don't believe the can't teach an old dog new tricks saying, personally. And, certainly people can master things at any point in life, but it does take time. And so, if you're looking for, bringing in expertise into your team, then 5 years, which is 10,000 hours, is what you want to look for. You want to do something complicated like automate your testing, then you need to look at people who have 5 years of test automation experience. Let me give you some examples of this case studies. Somewhat painful to recall, but in 2007, we had hired a company on the advice of a marketing firm we were working with to rebuild our website. I ended up trusting the marketing firm to make proper recommendations, so I didn't interview the people doing the work, and that was a mistake. It took 4 months to finish development, and if you go out and take a look at the RBCS website, you'll see, and this is not an excessively complicated thing, but nonetheless, it was beyond their ability to do, and like most of that 4 months was spent in endless cycles of bug fixing and testing. There were still quality problems after we went live because the time had dragged on so long. We just had to replace the website that we ended up going live with it with less than perfect quality. And we had a lock-in situation because there was proprietary technology involved, which I didn't know about. So it was, in short, a total disaster. And incompetence was a huge part of that. The people doing the work, very significant competence issues with these folks. Now, 2009, so we basically limped along for about 1.5 years with that website, which, it looked all right and it was functional, but it had a lot of issues with reliability, and we were very frustrated with it. So finally, I just reached a limit, and we hired another company to rebuild the site. I knew these people, had worked with them as part of my work with the ASTQB, and I knew that they were good and competent. So we went through, we basically, it was the exact same site. It was just building the site over again. The same development and test processes were followed. The only difference was the team. I mean, this is as close as you can get to a blind study in software engineering as I can imagine. The project wasn't perfect, but we did find bugs, but the quality was much higher, and we are using these guys on an ongoing basis to maintain our site. That's because they're competent, because they do good work. Now, one thing to point out here is, good people are a valued resource, and they should be. At least they should be a valued resource. So keep them. Keep your good people. Turnover is bad. Layoffs. People say, we have a reduction in force. Well, okay, if you're going to have a layoff, make sure that you go through some sort of exercise and you pick based on skill, that you know who the right people are to keep, because you don't want your intellectual capital walking out the door. And outsourcing any sort of decision as opposed to the work, critical decisions that will affect quality, that's a mistake. So be very careful with that. If you're in senior management, executive management, be prepared to make the critical decisions on your own. Don't hand those off to people outside of your company. You're going to have to delegate to managers within your company that's going to have to live with the consequences. Okay, manage change. Change is unavoidable. Change happens. Whether you're following an agile life cycle or a waterfall life cycle, change will happen. But change is not without risk. Any change has risks and costs, as well as opportunities and benefits associated with it. So every change should be evaluated on that basis. Do the benefits and opportunities outweigh the costs and risks? So, smart organizations can do this. This is not beyond people's mental capacity, but you have to not be, you can't just react to everything that comes along. So our clients that we work with that do this well, they have an orderly process, including right as they get to the end of a release. Other times we see clients just a lot of thrashing around and unmanaged change and so forth, and they end up being purely reactive organizations driven by the whim of the moment. Give you an example of this. We had a situation where we came in and did an assessment after a project had failed, basically, and what had happened was the organization had bought a off-the-shelf piece of software that could be customized as needed according to the vendor, but they thought it was ready to go, so they jumped right into user acceptance test, and basically the vendor told their customer, this bank, hey, anything you don't like, just report it as a bug. We'll fix it, no problem. And we don't need any requirements. Our requirement is we do everything you ask of us. UAT was originally scheduled for 6 weeks. There ended up being 800 bug reports, which on closer inspection, most of them were actually change requests masquerading as bug reports, and some of them were even of the nature of somebody basically saying, feature X exhibits behavior A, I don't like that, I want it to exhibit behavior B, and then feature X exhibits behavior B, I don't like that because this, that, and the other, please change it to be C. And then, eventually something like feature X exhibits behavior J, and on second thought now, I'd rather you just changed it back to A. So, it's a really incredibly frustrating situation for everybody involved. UAT, a 100% schedule overrun. It ballooned out to 12 weeks, and the project failed. And we came in after the fact to assess this failure. Now, in contrast to that, on another project, we had a cross-functional team that would triage bugs and evaluate changes as they came up, and we had group decision-making. We allowed a high rate of change early in testing, and as we got towards the end and the risks of change went up, we basically made it harder and harder to approve change. We all became more conservative in our weighing of the risks and the costs, and it was explicitly discussing risks and costs, opportunities, benefits on each decision. Pardon me. So, where are you on this? If you look at these 6 lessons that we talked about, how well are you doing? How poorly are you doing? What mistakes might you be making? What kinds of tips that I brought up could you apply? A quick self-assessment. And of course, if you want help with an assessment, that's certainly something that we can help you with. But one way or the other, whether you self-assess or you bring in a consulting firm like ours or some other consulting firm to take a look at where you are on quality, I think you really do need to think about these 6 areas and ask yourself how you're doing. None of it's particularly complicated, as you can see. I mean, these are basic things, and these are things that we know. We know all of this stuff. We've known this for years, but we just don't do it very well. So rather than letting failures in the field be your first sign that you've got quality problems, these 6 lessons will allow you, if properly applied, will allow you to deliver quality the first time right out the door. Okay, we'll put the advertisement up here as we go into the Q&A mode. Let me start by apologizing for the poor audio quality or any audio quality problems that occurred right at the beginning, and also for the interruption that occurred in the middle. I think somebody didn't get the memo about what I was doing and assumed that I was on less important phone call. I do apologize for those interruptions, and I appreciate everybody sticking with me on this. I see that the attendance numbers have stuck at their proper point throughout, so thank you for that. So with the presentation behind us, I'm going to take questions from the audience. Please submit any questions that you have using the webinar question feature. I'm going to go ahead and undock that. Just give me just a moment, please. Let's go to webinar software. It's a good product, and I'm happy with them, but sometimes usability can be something of an issue. Here we go. Okay, cool. First question from David. Are these slides available for download? Yes, they certainly are, David. As I mentioned, the introduction, which perhaps you missed, if you go out to rbcs-us.com and go click on the Resources tab and then select the Basic Library, then you'll find these PDF of these slides posted and available. Let's see. I have a question from Kiki. Could you please repeat lesson 6? Well, if you had some audio difficulties, then don't worry, there will be a recorded version of this webinar posted, and you can listen to the entire thing again in the next, probably week. Now, if you're just asking me to kind of summarize what lesson 6 is of managing change, basically, any change in the direction of a project after the initiation of the project has risks and costs associated with it, as well as opportunities and benefits. And different organizations have different levels of risk aversion and different levels of cost consciousness, so that that changes the change management, as it were, equation. So there's not like one size fits all, but there needs to be a collective decision-making process for deciding which changes to make and which ones not to make, and that must be aware of, as I said, risks and costs as well as opportunities and benefits. And I think even if you're doing Agile, and I know that the watchword of Agile is embrace change, that's embrace change does not mean jump around wildly like a drunken marionette at every twitch of the string, but rather, think about change in a reasonable and appropriate fashion. Okay. A question from Minetta. What is the most important focus for testing when a client is going from waterfall to agile development methodology? Wait, where to start with that one? Continuous integration is really important, and it's essential to, I think, the sort of the agile. Well, where we've seen agile work and work really well, continuous integration has been part of the mix. Good unit testing has been part of the mix. Using tools like fitness and the various XUnit tools and the mock object kind of tools that are available now, those are part of the mix. There needs to be automated regression testing at the user interface as well, or certainly right below it, perhaps. The unit testing that's done needs to be done competently, and that's a big part of it. And one of the things that we've seen is that programmers are not always aware of good test design techniques, both black box and white box. So that's something I encourage you to look into. For example, we have this testing for programmers course that we do to try to train programmers on how to write better unit tests and other types of tests. As well as to understand something that Nelson is bringing up here in a question about code coverage software. I mean, code coverage is, I think, an important part of good unit testing, having good code coverage, but people also have to understand what those code coverage metrics work. And we do run into we run into programmers who are using code coverage metrics without understanding what those do and do not tell them, and so they can become overly confident based on what the numbers are saying. So I'd say yes, you want to understand code coverage. I'm going to be doing some webinars on advanced software testing techniques from a white box perspective here coming up in the next 6 months. So stay tuned for that, and I'll talk a lot more about code coverage. I believe there actually is a recorded webinar on code coverage specifically that's available out on the digital library, the RBCS webpage. So if you want an overview of code coverage, go ahead and take a listen. Let's go to the rbcs-us.com, and on the resources page, select digital library and take a look. I'm pretty sure that that webinar is recorded and posted out there. Let's see. Eric asks, can you recommend a good tool for requirements management? I really hesitate talking about specific tools in these webinars, because if I say anything bad about anybody's tool or forget to mention somebody's tool, then I could get some irate email. And if I recommend something for you without knowing your exact circumstances, that might not work out well. What I would say is, just generally speaking, when you're looking at a tool, it's very important that before you start going and looking at specific tools and brands and websites, and sit down and think about, what are you trying to accomplish? What are your actual needs? What are your constraints? What are the realities that exist? And restrain yourself before you go jumping into the tool selection, because this is something that I think we tend to try to do in software engineering. I said that software engineering was one of the more under-automated forms of engineering, and that's certainly true. But ironically, I think what we tend to often do is jump into trying to acquire a tool to do something when we haven't really thought out exactly what it is we're trying to do. Drink of water there. Brian asks, any additional suggestion for convincing project management that taking the time to really define requirements is time well spent? Oh boy. Well, I guess it kind of depends on what the objection is. If the objection is requirements aren't important to quality, we just we have a shared collective vision about what we need to build, and that's fine. Then what I would suggest is that you look at instances where there have been actual production problems, quality problems that have arisen because a requirement was poorly defined in your organization. If not in your organization, in some other organization that's doing something similar to what you're trying to do on your project. The closer, if you have to use an example from outside, the closer that resembles your actual scenario, the better that will be. The examples that I gave in this webinar might be useful to you, perhaps, but try to tailor the message, get someone's attention. If the argument is, well, time is better spent introducing or creating new code than documenting requirements, then the counter argument to that is, well, if we don't know what we're building, how much of that code is actually taking us in the right direction versus how much is taking us in a totally wrong direction? Various studies have been done on this, and so if you look at Capers-Jones, for example, in his studies and his numbers, he reports that 20% of defects are introduced in requirements 25% in design, and that only a third of the defects are actually introduced in coding. So if you don't have requirements and design specifications at all, then I can only imagine that basically, you have requirements and you have design. The question is whether or not it's written down. The requirement exists. Now, if it exists as an amorphously held idea that has various shapes and sizes and colors and tastes, etc., in different people's minds, depending on their opinions, well, you definitely have a lot. Every one of those disagreements is a requirements defect. So by not specifying requirements, you really are creating a situation where, if anything, you're amplifying the number of defects you're going to get that are requirements-based, and you're maximizing the cost that you're going to pay for those defects, because instead of getting them out when they're cheap by correcting specifications, then you're going to instead wait and get them out when they're really expensive. Now, that said, Brian, I do want to be careful here. I'm not coming across as, and I hope not. I'm not saying the requirements have to be specified to a brutal and project killing level of detail. There's such a thing as enough documentation, and I can't tell you what that is, but I certainly you can see the symptoms of what happens when it's not there. And so if you're under specifying, you know it. There are going to be quality problems showing up as a result of that, cost problems and so forth, that's stuff that can be measured and stuff that can be demonstrated. So I would say try to do that. Kiki comments here. We usually do not get any document. Well, okay. Well, then that's definitely you're in an underspecified situation. If you're not getting anything at all, other than some sort of vague hand-waving explanation from somebody about, oh, go off and build me this, then you can say that's definitely going to be underspecified, and you'll be able to point at the cost. Now, the trouble is, of course, that culturally in the software engineering, there are enough anecdotes floating around out there about brilliant ideas that started out as a few scribbled words and pictures on the back of a napkin from a bar. And okay, yes, that does happen, but by analogy, I will point out that you will also see 80-year-old men or women smoking cigarettes. That doesn't mean that it's not a risky behavior. I mean, if you're smoking 2 packs of cigarettes a day, you've been doing it since you were 20 and you're 80-year-old, okay, that's fine. That's great. Good for you. Good for having such genetic resistance to the damage that can be done by that. But for most people, that's going to create some fairly significant health issues. And it's the same thing here. If you disregard, and it's with all of these lessons, if you disregard these, yes, you might get away with it once as an organization. You might get away with it twice as an organization. You might get away with it 3 or 4 times. But if you look in the aggregate across products and projects and organizations at these 6 lessons, organizations that consistently apply these, do they have better outcomes from a quality point of view and all that is associated with quality than organizations that do not? The answer is clearly yes. So, I think that's another way to approach this. If people are saying, well, we don't need to do any of that stuff because we've been fine so far. I mean, I think the argument based on sort of the epidemiology argument there of yeah, sure, we've gotten lucky so far, might be something that gets people's attention. Okay, I hope I've addressed the questions about requirements there. Let's see. I'm just going through the questions here. It's a few people had difficulty getting on earlier, but I see that seems to have been resolved. We're the attendance numbers held steady. So I do apologize to any of you who did have audio difficulties, and if you did, if you could send an email to info@rbcs-us.com and describe what that audio difficulty was, I would certainly appreciate that, and we'll make our gratitude known appropriately for more input on that. I got a question from Akiki here again. Can you elaborate more on managing risks, especially in an agile mode and requirements keep changing and new features are added in between development? Yeah, okay, so risk-based testing. I've done presentations on this and so forth, and pretty sure there's a recorded webinar out there on risk-based testing if you haven't heard me talk about it. And there's also a bunch of videos on YouTube. If you do the RBCS channel on YouTube, as well as accessible off of the digital library, the website, RBCS website, talk about risk-based testing. So there's plenty more on this, but here's like the really short version of risk-based testing in an agile environment. Basically, classic waterfall risk-based testing, what you do is parallel with the requirement specification. You do with the development of the requirement specification, you do a risk analysis, quality risk analysis that generates a list of quality risk items. And then you assess each of those quality risk items in terms of likelihood and impact. And those two factors together determine the level of risk, and then you test according to the level of risk. The higher the risk, the more you test, the lower the risk, the less you test. And you also sequence the tests in terms of risk. So the higher the risk, the earlier you test, the lower the risk, the later you test. And this allows you to optimize the risk reduction that occurs when you're running your tests. Now, here's what happens in Agile. In Agile, what you do is you do, because the requirement specification process is one which is more or less ongoing with this generation and what's sometimes called grooming of user stories. As part of the process of finalizing a user story, you identify the quality risks that are inherent to that story, or you identify existing quality risks that were identified for previous stories and that might be affected by this new user story. And you then basically, appropriately enough, iteratively add to this quality risk item register or library or inventory, whatever you want to call it. And you, of course, assess likelihood and impact for the risks, and then you test accordingly. Now, the thing that's different somewhat in Agile is that in Agile, you have to make sure that the user stories are built in risk order as well, because user stories should be tested as soon as they're built. There's not, unlike the waterfall or V model, there's not the concept of system test entry criteria that says that we wait for all of the features to be complete before we start the testing of any of the features in a system test world. With continuous integration and user stories being turned into code and integrated, you're basically constantly in a system test mode, and you should be starting testing of the feature as soon as it's delivered to you. And so what that means is that the development has to be in on the act, basically. They have to be involved in the risk analysis, and they also then have to use the risk analysis to determine the order in which stories are built. Now, this should not be an imposition on them, because you're talking about doing things based on likelihood of problems and impact should those problems occur. Well, in terms of likelihood, you'd expect that people would want to eliminate bugs from an iteration as early as possible. Developers and everybody. So that should be intuitive to them. And in terms of impact, certainly the business stakeholders are going to want to see the most important features, those being the ones that will be associated with the highest impact of potential problems, as soon as possible. So I think it's in everybody's best interest in an agile world to build and test in risk order. Okay. Now, a question came up about PMI PDUs. Joe asked about PMI PDUs. And some of our webinars do indeed have PMI PDUs. And the way that you know is when the invite goes out, the invite had a PMI logo on it, then you get PDUs. Also, what happens is if you do get PDUs for a webinar, the follow-up email that you will get from GoToWebinar will tell you the PDU code. So basically, Joe, just wait on that question. I believe that this is one of the ones that does, but I can't remember right now off the top of my head the process as well as submitting it for a review and it gets approved, and that happens so far in advance of the webinar that I don't keep track of which ones aren't, but I think this one is. But anyway, you should receive a follow-up email in the next few days, all of you should, that says, you know, if this is PMI, PDU eligible, and if it is, it'll give you the code. So if in a week you haven't gotten a follow-up message, check your spam folder, as I said. In fact, do that in the next couple days for that for the free e-learning drawing. Someone will get notified. You know, if the problem hasn't been resolved in a week in terms of, you know, where's the follow-up notification, let me know. Again, like with the audio thing, anytime there's a glitch in these webinars, I'm certainly happy to get notification from you guys. Kiki says, session has been very helpful. Thanks. Thank you for attending, and thank you for your participation, which has been quite good. Joe says, thanks, Rex. Even without the PDUs, the webinar as well as the wealth of info posted on your website is phenomenal. Okay, well, thank you for saying that, Joe. That's great. It's really very gratifying and to hear that, and I'm glad that you're all taking advantage of that stuff. We're going to have our new webinar schedule up for at least the first half of 2011 very soon now, and of course you'll all get invites for the next webinar, which will be happening in February here shortly. So watch for that. And in the meantime, yeah, go to the RBCS website for more stuff. Now, Kiki has a question here. Is there a blog somewhere that I can follow? Yes, there is. So if you go to the RBCS website, rbcs-us.com, there's the RBCS blog, well populated with all sorts of existing postings that might be of use to you. I try to avoid topical kind of stuff that ages. It's there's a lot of material out there. I try to post about once a week. I've been kind of busy lately, but do try to get a post out there once a week. So feel free to take a look at that. If you want to start a dialogue with me on any of the topics that I've got a blog post about, that's the place to do it. So happy to get some discussion going. So take a look at the blog and you know, make a comment on one of the postings there, and I will respond. Let's see. So to close this session, let me tell you a little bit more about some of these resources that are available through RBCS. Webinars happen once a month. They are 100% free. Check at rbcs-us.com to sign up, and feel free to forward these on to your friends. We've got room for more people. We have to pay a higher level at some point or another, but we've got room for up to 1,000 people, and we're not there yet. So forward them on. If you want a special webinar presentation for your company only of this webinar or on any other topic related to software testing, then you can contact us at info@rbcs-us.com or via our website. If you do not already receive our free newsletter, you sign up for that at rbcs-us.com as well. And if you sign up, you'll get valuable discounts on consulting and training services and a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can follow us on Twitter at twitter.com/RBCS, and we try to get a post up there every couple days about things that are going on and things that are topical, as well as discounts and so forth. And you can also find us on Facebook at facebook.com/pages/rbcs-inc. As I said, check your email over the next couple days, including your spam folder if you've got one. You might be the lucky winner of a free e-learning course from RBCS. You will register for a random drawing for such a course simply by attending this free webinar. And check out the digital library. The recordings of these webinars, like for example, this one will be posted here in the next week. Podcasts, videos, etc. You can subscribe to our podcast via iTunes, enter RBCS podcast into the search string on the iTunes store, and you can see videos and recorded webinars by subscribing to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community because at RBCS, as I said before, we are a not just for profit company. This concludes the webinar. I want to thank all of you for joining us today and wish everyone a great coming year. Goodbye.